Thanks for coming today.
Welcome to this talk. We will be talking a little bit about, well, call it data-driven programming or the processing of data in Java. You can start with introducing yourself.
Yeah, so a little bit about myself. So my name is Raab. I am a managing director and distinguished engineer at Bank of New York Mellon. I'm a Java champion. I am the creator of the Eclipse Collections Library, if you've ever heard of it. It's an open source collections library. I was a member of the JSR 335 expert group that got lambdas and streams into the Java 8, and also was a contributing author to 97 Things Every Java Programmer Should Know. So that's a bit about me, and then on to Rustam.
And my name is Rustam. I am a chief engineer at a company called Compitos. It's a consultancy company in Oslo, Norway. Well, we have several offices, but I work and live in Oslo, Norway. I'm also a Java champion. I'm a Google developer expert for cloud technologies. And also I run a few communities there was a very, very, very fun thing back in the days called Java 1 Rockstars that, some of us hold very near and dear. So today we will be talking a little bit about streams. We'll be talking a little bit about Eclipse collections or collections in general. I'll be talking a little bit about a data frame. Traditionally, a lot of people have been working with data. You probably have experienced working with or have heard about things like pandas or things similar to that. And usually it's not usually in Java. But we wanted to show that it's actually possible to do that, and it's possible to do it on different levels. So we needed the problem, and then we came up with this thing. Well, since we are kind of serial speakers. We travel to different conferences and do talks for fun and for sharing knowledge and everything. So we decided to use conference data, surprise, surprise, to process and to show how you can process all that kind of data. We wanted to look at how you can do it in an effective way, in different, like I said, in different levels of abstraction. We'll look into that. What we mean by that in a second. And we also wanted to look at different options. So Java Streams, that's the thing that comes pretty much built in, or actually built in inside the Java distribution that you have installed. And also third-party libraries like Eclipse collections, and also something called Dataframe EC. Both of them are open source libraries. One is under Eclipse Foundation, Eclipse Collections, and the other one is an open source library created by a guy called Vlad Zakharov.
Yeah, and I guess just something I would add on that, as we were building out this talk and coming up with the solutions that we're about to walk through with you, we had a lot of interaction with Vlad, the creator of Dataframe EC, on using the library. And actually, because it's open source, we were making suggestions and actually getting some changes to the library that we were seeing use cases for our particular conference talks.
So this, I usually say it on some of the talks I do, and I think it's really, really fitting to say here as well. We're going to show you a library, so we're going to explain how things work and everything, but also we want to encourage you to, this learning by tinkering kind of thing, right? You want to learn something, you want to understand how it works, you want to improve something, start using it and see where it gets you, and submit bug reports, submit pull requests, keep on improving it, and it will get eventually better. So that's a little bit of a kind of a slightly hidden agenda kind of thing for this talk as well. Right. So the first thing you do when you work with data, you need to import it somehow. So the data that we've been working with, we have been using as an example, it's basically a list of different conferences at which, this is a little small subset of conferences that either of us, either me or Donald or both of us, will be talking at this half a year. And we just put up an event name, we did so we have a country, a city, when does the conference start, when does it end, and what kind of sessions do you have? Do you have like talks like this one, or you have workshops, or you have both, or so on, so on, so on. So this is a pretty printed version of a CSV file. I mean, actually behind this thing, it's actually a CSV file. It's just ASCII doc is doing a really nice job of presenting it as a table. So just imagine the same thing with just commas in between there. What's worth mentioning here is that the session types is actually, if you can see, it's actually a list. So it has this little squared parenthesis and a bunch of values there. Anything else? No.
No, that's good.
Let's go. Let's jump into the, what do we choose?
So I think, one of the things Rustam and I looked at was the analogy for, the libraries. Was there something that we could come up with? And if you look at these libraries, we look at them as basically, they're the building blocks potentially for your application, right? So a good analogy from that perspective is the ultimate building block is Lego, right? At the streams level, collections level, and even at the data frame level, you've got low-level building blocks that you're going to build your app out of.
Just like, to wake you up, how many of you have played with Lego? Right, good. Okay, I'll need to keep mine in both hands too.
I have two kids, so I have more Legos in my house than,
I mean, I don't. I have a lot of
If you haven't played with Lego, come over to my house, we'll play with Lego.
All right, okay, so yeah, you were saying, sorry.
Yeah, so we had additionally, looking at Lego, Lego, if you're not familiar with it, has different brick systems available to it. So there's the most common brick system, which I guess you'd call the classic, which is pictured at the top here. We thought that equates really nicely with the Java streams because it's something that most developers will be familiar with. Most Lego, builders will be familiar with the classic brick system, and you can pretty much build most everything that you would want. There's another brick system called Technic, which is more advanced, typically for the sets, and you see the picture here of a Bugatti set that I have yet to build, mostly because it's 3,000 some odd pieces, and it's going to take me quite a few days or weeks. It'll take my son probably 2 hours, but it would take me a long time to build. So. But you have more customized parts, different shapes. They're still compatible with the existing brick system, but basically there's a lot more in this brick system, and they're typically much more specialized. And we thought that was a good correlation or relation to Eclipse collections, which if you compare Eclipse collections to the native Java collections, you get a bunch more types. You get things like primitive collections. You get performance optimizations, right? They're compatible with the existing JDK collections, but there's a lot more built on top of it. And it's really a much bigger thing, which then requires you to spend more time learning and investing in it. So.
And Technic also have these things you probably have seen with cars and everything, it would have moving parts and engines and gearboxes and everything. You just pulled it from small pieces and it just fits together and just works, right? It's kind of the same thing with Eclipse collections as well. You just you can just build those with specialist parts, but you can build easier things together.
Yeah. Now, the last thing you've got on here is for Dataframe EC, we thought a good analogy was Lego Mindstorms. Has anybody used Lego Mindstorms? No? Just me?
I think it was one hand there, or two.
Great. So Lego Mindstorms is a robotics building kit that Lego's had around, I think, since the early 2000s. They've gone through 3 generations. What you have pictured here is actually a Lego Mindstorms crawler robot. It's got tracks on the bottom. I don't know if you can pick that up. It's got various sensors, but in the center of the robot is what they call a brick, which is basically, it's programmable. It's the thing that you can hook sensors up to or motors and basically program it. And Lego Mindstorms is actually built on top of Lego Technic, so it's exactly the same system. We thought that was a good analogy for Dataframe EC as a data frame library and a higher level of abstraction. Actually, it's built on top of Eclipse collections.
That's the EC part, right?
Yeah,
that's
exactly.
where it comes from, right?
That's the EC part. So, so that's a bit about that. And I think because it's got the programmable brick, it's actually easier to, let's say, build a robot, follow the instructions using Lego Mindstorms. It's got a more limited set of parts than, let's say, a typical, a Technic kit like the Bugatti here. So it's somewhat, I think they target it towards age 10 plus. So it's somewhere in between the basic brick system and Lego Technic in terms of.
We kind of thought it was a kind of entertaining to add age limits to that, because this is age limits just for off the box. But you can also see like, Java streams, 9+, you can do it.
How many people use Java streams?
Good. Perfect.
Okay, a lot more. Good. That's what you're expecting.
So that's the kind of the basic, the lowest level you can do with all the processing of data and everything. And then, what's that? 16+ is for Eclipse collections, apparently. But still, Dataframe EC, it's still easier, but it's more complicated at the same time. So younger kids can do it, but it still gives you more specialized experiences to that as well. So that's fortunately or unfortunately, I'm not sure this is the last slide we're going to have about Lego. From now on, there will be code on the screen.
Lots of code.
Lots of code.
Okay, so
Go ahead.
just looking at this, so Rustam described the problem we were looking to solve, right, which is loading CSV data about conferences. And in terms of the solutions that we came up with, we decided we were going to have a conference explorer. And for Java streams and Eclipse collections, the Conference Explorer will load the data into an immutable set. In Java streams, using a JDK collection, it's just the set interface. In Eclipse collections, the Conference Explorer holds on to 2 immutable sets for conference and country. Now, the interesting bit with using a collections library to do data-oriented programming is that you need to actually design a type. So what we did here was actually use Java records to reduce the amount of boilerplate and stuff that we have to create to actually then load this type. So you can see both streams and the Eclipse collection solutions are using set of conference, and the conference type is a record, right? And that's pretty much how we define it. There are methods in addition that I don't have here, but this is the basic structure. And you can see it matches to the data that Rustam was showing, which is the event name. You've got some country, which we've also made an object, and it's also a record. A city, start and end date, and then a set of the session types.
Because when you're playing around with data, you take a tabular data, right? CSV, it's a kind of tabular data. It's just rows of data and columns and stuff. You need to convert that into some kind of objects if you're going to work with it in object-oriented language. So this is what we're doing here. We're creating objects that kind of fits our reality of how we think and we look at our data. So we have like, conference and countries and all these kind of things. Probably the biggest exception here will be the data frame, where it's going to be just a data frame object. You just do a lot of stuff to it instead of creating all the data model objects of
and a good way to think about a data frame is basically it's a tabular data structure that has columns and rows, right?
Yep.
And that's how you query the data in it. So I guess just to real quickly, so the 3 things we're going to do here, we're reading some data in. We're going to do a bunch of different processing against that data, sorting it, grouping it, counting things in it, getting unique elements for things. And then we have input, we have processing, we thought we need output, so let's output to JSON. So we actually show how we output to JSON. And across the board, we're using the Jackson JSON serialization library for that. So.
All right. So,
okay.
Tests.
Yes, tests. So as Rustam and I were working on this together, he's over in Norway, I'm over here in the States, we thought like, hey, let's build out a set of tests that we want to implement across all 3 of these solutions. And there's a test class for each one, Conference Explorer Test, and these are the set of tests that we basically have. It's for loading the data, for doing the different processing like grouping, sorting, counting, summing, and then actually testing out the JSON output as well. There are links on each one of these that links to the various tests that actually show what we're testing and how it's done. And we may be jumping into these as we're going through the slides. I won't do that now, but I'll jump to the next slide. But the whole point was like, anytime we did something, everything was being driven by these tests that we came up with for the different types of processing that we wanted to demonstrate.
And it's very handy when you change a little bit of implementation, you try new things, you want to do that, you just rerun your tests and you're like, it actually still works. Or, oh, I broke something, kind of thing. Okay, so this is probably the most busy slide you will see today, so bear with us for a little bit. But all you need to do is just read it section by section. Don't try to parse the whole thing for now. Here we just need the first step, right? Reading stuff into a CSV file. From CSV file into the objects. And most of the stuff here that you see, it's a kind of a bit of declaration of a schema, CSV schema, and the URL declarations and all this kind of thing. So probably the most important part, and by the way, if I think it's actually visible quite well. So you can see that we try to highlight the most important lines. So you see that some of the lines, numbers on the next to the code will be a little bit bolder font.
Yeah. And I would say the most important thing on this slide as well is the stream and Eclipse collection solutions should almost look identical.
Yeah.
Because they're pretty much doing the same thing. They're using Jackson for the loading. So these are Jackson classes like CSV mapper, mapping iterator. The data is being read in using Jackson from the CSV file into effectively a list of maps, where a map represents each row. It's a list of rows. Each map is an individual row. And that's where like IT read all on each of those solutions actually is reading in that list of maps, which then iterating over that, we create the conference records and put them into either of the sets.
And actually, you'll see a lot of this kind of things, like on a lot of slides, you'll be seeing that Eclipse collections, Java streams almost kind of look the same, but the Eclipse collections part will be often a little bit easier. It will provide you a little bit more auto magic, auto kind of doing some stuff with a little bit less method calls and all this kind of stuff. So that was the first two. And the last one is a little bit different because here you read into the one object called Dataframe, and that Dataframe object has already methods for reading from CSV. So you just like to import CSV, kind of like what you would expect from, I don't know, let's say Pandas or something similar, right?
Yeah. So pretty much you don't need Jackson to read CSV with Dataframe. It's already built in.
So what you can think about, I don't know, at least it helped me to think about this in this way, is that both Java streams and Eclipse collections is more of a like object-oriented objects and stuff, while Dataframe is more of importing your data into some kind of spreadsheet software where both data and all the operations you do on data are kind of living all into one object. So if you think of a spreadsheet file as one object, well, that's kind of what you will be seeing here as well. Bit different, but yeah. All right, so first kind of calculation thing. So now we've imported the data. So now we need to do some kind of calculated values. And that is the typical thing you would do when you need to work with data. So we decided to calculate days to the event. So you basically take today date, and do the calculation and compare it to the event start date.
And you'll see here, there's only one piece of code here for both streams and Eclipse collections because they're effectively the same code for implementing this method on the record class, the conference record.
And yeah, and for those two, we also use the record object. So we have a conference record that has this little function that calculates and returns the value. So those are pretty simple. For Dataframe, it's a bit different because here you actually need to do a little bit more work because, well, pretty much the same thing, but you do define it as an inline function. You remember, our Dataframe object is a kind of a spreadsheet document, so you need to create that function and define that function within that spreadsheet thing. And then you just, say what kind of value it's going to return and what it's going to do and how it's going to do and all these kind of things. This is what we do here with intrinsic function descriptor builder using builder pattern.
Just to read this quickly too, what we did was we attached a daysutil function to the data frame, and for this particular column we call days to event, we have an expression we execute, which is using the days until function, passing the start date, right? So you've attached the function, you've then created this derived column effectively, and that's now available then for your data frame to process, which is, it's different than, as Rustam's saying, with the object-oriented approach, we just put a method on an object. There's no object to put on. You can't add a new method to the data frame, but this is how you attach a function to it and attach, dynamic columns.
And we'll see more of calculated values and calculated columns in a bit. So this is just the beginning. All right, so that's the typical thing you do with calculating things. Now we can talk a little bit more about grouping stuff, because if you think of databases, typical SQL kind of queries, you want to do group bys, you want to do counts, sums, all these kind of things. And
yeah, so I think, if you look at group by and, similar to on the previous slide with sort by, you're going to have different methods available in the different frameworks for doing these things. With group by, in the stream space, if you've ever done this, you can use a collector. You can use the grouping by collector. And in our case, what we wanted to do is a group by to an immutable set. By default, if you use a group grouping by collector with streams, it'll return a list. We wanted actually a map, it'll be a map of some type to list. We wanted a map of some type to set. So we use the grouping by collector along with a downstream collector called collectors to unmodifiable set. I forget which version of Java that was added in. It was maybe Java 10 or somewhere around there. It was definitely after 8. So with Eclipse collections, you've got a few things going on here. So Eclipse collections has methods directly on the collections themselves. So you don't actually have to call something like stream or something will be done lazily. The conferences, if you recall, is an immutable set. And when we call group by on it, group by is defined covariantly across all of the different types in Eclipse collections. So for an immutable set, what group by is going to return is a special type called an immutable set multimap, right? If it was a list, it would return an immutable list, if it was an immutable list, it would return an immutable list multimap, right? So you get some convenience out of that in terms of the different types knowing for specific APIs what types they should return by default. You can control the return types if you want. In this case, it was actually just convenient for us to get back the immutable set multimap. And you can see we're just using a method reference in both cases off the record to group by the country. And we get back map of country to set or immutable set multimap of country to conference. And I think if you look at Dataframe EC, it's a bit different, right? So we're doing something different here. Dataframe EC actually has a concept of an index. So on a data frame, you can index the data frame on whatever you want. You can create multiple indexes as well. So in our case, we wanted to create an index for country, right? Where we're, so you can see we're giving a name of country, we're using an attribute of country, this creates the index, and then we're actually returning it. And separately, I think what we can do is just show you, if you click here, and you get the slides, ooh.
Yeah, just pinch, I think. No? Yeah, it works.
Okay. You'll actually see the code for the test that we do. And when we get back the index going, you can see so we call group by country, then we want to iterate at Greece, right? And verify that we actually have Athens in the result set for that index, right? So we wanted to basically show, it's one thing to show, hey, here's a code we implemented. It's another thing to say okay, what was the test that was actually using this code? Because it's the usage versus the code you had to write. So command.
Command Alt. Yeah,
there we go. Okay, we're back.
So that's a cool thing. And also we've been a little bit back and forth. Should we just add index onto data frame and just return data frame? And it kind of felt weird. So we actually ended up returning a df index object, which is just a directly index object. So you actually can iterate through that. But technically you can do it in both ways. You can actually just attach that and build that index onto the data frame objects and just let it be there.
Yeah. I think for group by city, it's going to be pretty much the same approach. You're going to see something very similar looking for all three solutions, right? It's just going by city instead of country. So I'm not going to dive into those.
No.
The next kind of, API we want to use, algorithm, is counting stuff. So with Java streams, you have the ability to use grouping by with a downstream collector called counting. This will create a map of some type to long. So we have a map of country to the counts for each country. So we want to see how many conferences are in each country, right? And this is the code to do it for streams. For Eclipse collections, there is both a specific API that's eager on the types called count by, and there's a different result type. One of the extra pieces that come in the Lego Technic kit, for Eclipse collections, we have a bag type. So a bag type is very similar to a map of some key to an integer. Underneath bag, we're actually using a primitive collection. So we use object int map as the implementation, which gives you both performance and memory savings. But the interesting thing here is you get back a specific type. Now the differences between map and bag are very interesting in that you get specialized APIs for bag. With a map, you have to be careful when you have a sparsely populated map. If you look up a key that does not exist, the result that you're going to get back is null. If you look in a bag and you say, what are the occurrences of a key that does not exist, the result is 0. So I would say it's much more null safe to actually have a specialized type that knows how to deal with counting than to use a map as the structure. With data frame, it's interesting. There is an aggregate by function on the data frame itself, and you can specify with a thing called aggregate function the type of function you want to apply. And in this case, we want to apply a count, and we're counting country, creating a column called country count. And what we come back here is, from our source data frame of conferences, we come back with a data frame of just country and count in 2 different columns. So a brand new data frame with the data in it counted, which is kind of interesting. So I think the interesting thing on this slide is really compare the different result types you get from each of the frameworks, right? They're all giving you the equivalent thing, which is the country to count. I'll go quickly. So count by month. The most interesting thing on this one is that month itself, similar to like days to event, is calculated, right? So we wanted to show like, hey, we can actually count by something that's dynamically populated. So month, we have to actually get off the start date, ask the local date for the month. Now each of the frameworks actually does, in this particular use case, we're using local dates for the records for streams and Eclipse collections, and local date is already built into a data frame as well. So they're all using local date for the work code. That's that, and we'll go to there.
All right. So next thing. Now we want to sum conference days by country. So now you're doing a bit more. You're not just counting one attribute or calculating another attribute and counting one of those. Now we want to see how many days of conference events are per country. So you have to do 2 different things. And here, again, you can do the solutions for Java Streams and Eclipse collections seem pretty similar, with a little bit of difference, where you don't have to do, where for Eclipse collections, you just apply directly to the conferences object. You just say sum by long, and then you say, well, I want to sum the conference by country, and I want to calculate the duration in days. Oh, this is nice. That's the fun part of doing things in the IDE. You get all the fun things. All right, I think we're good. So, but for the data frame EC is a little bit different. So here you actually already have a built-in function that does sum by, and this is, again, I mean, you don't really have to do like data frame to use that data frame. If you want to use any other library, you're fine to do that, and you probably would expect something, function like that available there. But here you just do sum by, and then the only thing is, the funny thing is that you need to think a little bit, you need to kind of swap those 2 parameters, right? You do sum by duration by country, which kind of reads better, I guess, like semantically. You can actually read the code and say it in human words and sentences, and it still makes sense. For the other ones, it still makes sense, but you need to be a little bit careful how you pronounce it, right?
It is interesting looking at the types on this as well, similar to like count by, which you had map, bag, and data frame as the return types. Here you've got map, object long map, which is one of those extra things you get in the Eclipse collection as a primitive map type. Now what's interesting there is technically you should have you can have a sparsely populated map, but anytime you're doing a lookup, you're always getting back a long, right? So it can't be null, it's going to be 0, right?
Yeah. All right, so now we want to talk a little bit more about how do you do distinct. So basically, if you've used SQL, you probably have been using distinct in one way or another. So this is a similar kind of thing. Here we're actually doing 2 things. So we're getting a distinct list of countries, and then we're calculating a country flags. So to do things a bit more funny and, well, at least fun, not funny, but we wanted to create a flag emojis for countries. To do that, we needed to have an idea of how the country codes are, because like typically, just to explain you real quick how this works, a country flags are generated by the country code, 2-letter country code. So for USA, that would be US. For Norway, it will be NO. For Sweden, it's like SE, and so on and so on. And then you take a UTF-8, so a byte for a character S and byte for a character E. You put them together, you mash them together, and then it becomes like a Swedish flag. Or Norwegian would be N and O, and so on and so on, right?
That was a cool thing I learned during this. Like, I love coding with emojis, but I didn't actually know you could take surrogate pairs and combine them like that.
Surrogate pairs are really fun. So it all started with now we're really going off the track, but it all started with like my little project where I was tracking all the conferences, all the talks I've done, and generating statistics and generating a little list of flags. You know, it was really fun. I had like a list of, I'm collecting emoji flags for all the countries I've been speaking at. So this is where it came from. And
you want to go to the test?
For this one?
Yeah.
All right.
It won't be too huge.
Okay, let's see. Group by country. Where is
okay,
it? There.
Here you can see we're actually testing using the emojis, right, with the flags.
Yeah.
And we expect that that's the data frame that comes back once we actually get the unique country flags.
And yeah, so that's the thing. And then if you can actually see, if I select this thing, you can actually select half of the flag. That's the first character, and that's actually the second character. So it's a thing. All right, let's see. Yeah.
Command option.
Come on, option.
Back.
That was, all right. Yeah,
Back
yeah, there you go. All right, so, and the other thing, the cool thing here, actually, we are doing, with the first two options, we have put all that calculated while we imported that file with country codes and all this, and the all knowledge of how to generate emojis. We already put that into the object of our object model, right?
Yeah. So the only problem to solve there is like we have a set of conferences and we need to get to a set of countries.
Yeah.
Right. So for maps, for streams, so you need to map to the country via method reference, but then you need to collect that into a set, right? Then for Eclipse collections, because immutable set has a covariant defined method on it, collect, which is the equivalent of map, will also return an immutable set. So you don't need to say convert it to set; it's already going to come back with a set.
And for the last one, we needed to go full SQL kind of way. I mean, not really, but you can see there is some similarities. You'll recognize those things. So basically what we're doing, we're first picking up all the conferences, then we do a distinct list of countries out of it, and then you do a join. I think, if I'm not mistaken, that's left join. So basically you do the join into the, you have two data frames, one with all the countries. You have another data frame, another table with all the countries and codes, and then you kind of map those using join. So typically what you would do in SQL as well. And then you do, you say match, you say which columns that's supposed to be matching. So it's, they're in this case, they're both called countries. So country in one data frame, country in another data frame. You give a name to the new calculated column called, well, we called it alpha2 code because it's alpha values are 2 letters. So 2 alpha2 values of the code.
It's the toFlag emoji function, which was also attached to the data frame we're not showing here, that actually does the figuring out what the combining of the two characters to actually create the emoji.
But the good thing, all of the code is actually available on GitHub. We'll get back to that in a second.
This would be a workshop if we showed you it all.
Have a look at that as well. So you do that, and the last thing I want to mention here is also this if absent thing. So if there is no mapping, it will actually give you an error, and to make it most visible, I put like a asterisk there and like said, well, it's unknown, and like, blink red to me, so there is probably something wrong with the data set or something like that. Also another thing, I was like, there was a fun thing, it's like there's a bunch of different names that countries usually go for. Like, is it Netherlands, the Netherlands, Holland? There will be like different, and same with United States of America, US, United States, there is a lot of different options to that. So, you needed to think about this kind of things as well. All right, enough about going full nerd on emojis, I think, for now.
Yep.
Now we've done a lot of things to our data, right? We counted, we sorted, we've had a lot of fun doing that. Now we want to export the data into something where we can store it, right? We've calculated all the statistics, we've done all the crazy stuff with our conference data. Now we need to store it or export it or expose it somehow to the end user. So here comes the output into JSON. We decided to go for JSON. I mean, we could have done it with CSV as well, but it's a brave new world. It's microservices, RESTful services, and all that, and we love JSON. We don't like the other one. No, we're not going there. We like JSON.
Yeah.
No one mentions YAML. But anyway. Here, we needed to do some mapping back into this tabular kind of data, right? You want to do the Java streams?
Yeah, so with the Java streams, pretty much the only thing we have to do with Jackson, because the basic types like set and map and list are all kind of like part of the core library, we have to add the special Java time module to handle local dates as well. So we do that, and pretty much like that's all that's necessary. So pretty much any result that we wanted to write out, and we tried with different results. We tried with the result of sort by, the result of group by. It's like we wanted to output like dump maps and everything out. So so pretty much just have to add the Java time module. With Eclipse collections, we have to have the Java time module, and there's a separate Jackson module. There's a project called Jackson Data Types Collections, and there are different collections frameworks that are covered by that. You've got things like Guava, HPPC, Eclipse collections is one of them. I forget what the fourth is, but so we had to register that module as well. And that will handle the Eclipse collections types. Now the interesting thing with the Eclipse collections types, what I did here, and we're actually using Java 20, and if you look at the code from lines 3 to 6, this is actually using pattern matching for switch, which is in its 4th preview in Java 20. So what I needed to do is, I'm switching on the result. So I see if I get a bag, if I output a bag natively with Eclipse collections, a bag looks like a collection to Eclipse collections. It implements the collection interface. So if I've got, let's say, a bag of fruit with like fruit and counts underneath that's stored in a map, the way it actually looks out to the outside world is it's going to have like, if I have 3 apples, it'll be like apple, 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 right? So what I do here is for bag, I want it to switch and say, okay, on bag, make it look like a map coming out, right? Because otherwise it would look like a straight collection. But then everything else, go to default, right? So
because like for the first two, especially for Java streams, it's a typical regular, in quotes, objects that the object mapper for JSON knows how to handle. Yep. It knows how to convert that, whatever complex object that is, into some kind of string pre-printed version of that. Same with Eclipse collections, but it needed a little bit of implementation, and it's already implemented, but so you're just utilizing those mappers that are made specifically for Eclipse collections. For Dataframe, since it's a relatively new and smaller kind of framework, there was none. So you actually had to implement a way of handling Dataframe objects and serializing that into JSON, and so I had to kind of sit down and write my own little custom serializer for Dataframe.
Yeah, so if you've never had to write your own serializer, which I've never had to write one, you could, I guess, learn from this. If you've written one before and you can actually tell us how we can improve the one Rustam wrote, we'd love to have the feedback.
That was a very, very simple thing, and it just like, I've never done this before. I just sat down and started writing, and it just worked at some point. And I was like, okay, this is cool. I learned something new today. So, back to learning by tinkering kind of thing. So what happens here is it's pretty much the same as 2 other options, with a little bit more stuff happening. So you define custom serializer, Dataframe custom serializer, I called it. You create a simple module, and then you do module add serializer. So attach serializer to that module, and then you register that module inside the object serializer. This is how object mapper in Jackson works. So pretty much that. All right.
So I think we're going to go, for each of the frameworks, we just talk a little bit about pros and cons. So obviously one of the pros for Java Streams is it's built into the Java language. And the nice thing is it's actually continuing to evolve. You do get new behaviors added over time and like new features. So it's like, check the latest versions of Java to see what you have available to use. There are extensive books and training out there on streams. So there's probably talks at this conference in addition to ours about streams. So streams is great because it's built into Java and it can immediately leverage any of the data-oriented kind of language features that are being introduced. So Record is very conducive to doing data-oriented programming where you don't have the same boilerplate problems of getters and setters and all this stuff that you have to define. You can very quickly define a type that's immutable and is a very good data holder, right? Large pool of skilled resources out there. I think I saw a lot of hands out there, people already using streams, so you're part of the skilled resource base referring to here. So interestingly, JDK is open source, but it can take time if you contribute to the JDK, and I've contributed some things myself, at least in terms of ideas. It can take a lot of time. I have not built up the credibility yet where I could actually contribute something in terms of code, but I've started at least with ideas. And so it takes time to earn that credibility. If you sign the Oracle contributor agreement, it is open source. You can contribute. It can just be, a challenge maybe to get over building up that through the meritocracy. So some of the cons, you get a little bit more verbosity, right? You've got the problem with you have no direct methods on the collections themselves. So you've got always to go to stream, do some processing, and then have some output type. You're missing some of the null safe result types you get for grouping by and for counting. As we saw, you get maps for both of those things, right? Which can give you null values looking up keys that are in there. And it does require some CSV and JSON dependency if you want to use it. We use Jackson. There are other options out there if you want to use them. So.
And also this verbosity it can be a bad thing, but can be also a good thing because you have much more control. It's fine-grained. It's you can write assembly. Well, it's a bit more complicated, but you have much more control than doing something high.
Yeah, I mean, what you were able to see as well, for each of these frameworks, we were able to solve the problems without a ton of code.
Yeah. So now Eclipse collections.
Yeah. So, and obviously you got the disclaimer up front. I am the creator of Eclipse collections, so it does have a rich and well, I wouldn't actually say concise. I would say comprehensive, maybe API. You got the null safe result types we talked about. For group by, you got multi-map. For count by, you've got bag. It does have primitive collection support. There are extensive katas out there. You're not going to see a lot of talks at conferences. You will see a talk maybe for me at a conference on Eclipse collections, but there are a lot of katas out there where we've used katas as a way of teaching people to, via hands-on exercises, how to learn the framework. It is open source at the Eclipse Foundation. Contributions are welcome. You do have to sign the Eclipse contributor agreement, so as long as you're okay doing that, happy to take contributions. The downsides, I would say, of Eclipse collections is it's a third-party dependency. People like to limit the dependency, so that's an issue. Then, yeah, it's a con. There are less available resources out there. How many people know Eclipse collections?
Nice.
Okay.
That's good.
Handful, which is good. And I think, over time, hopefully that increases. But yeah, it's not as many people as know streams, right? And it has the same dependency problem, right? For CSV and JSON, you're going to take another third-party dependency.
And also, signing a CCA is pretty. I mean, it's a little bit of you need to do. It's a little bit of legal stuff, but it's pretty easy. I've done it. I've submitted some things to some contributions. It's not really too much work, and then you can actually also contribute to other Eclipse Foundation software open source projects as well. So last thing, it is the Dataframe EC part. So what is, well, the pros, it's even higher level, right? You have a lower level of the streams, you have a bit, well, much higher level of Eclipse collections, and then you have a Dataframe object that's built on top of Eclipse collections that has a really, I would say, rich and really nice and comprehensive and, well, concise API. It has a built-in support for a bunch of things of massaging and playing around with data, like, for example, support for CSV. It has flexibility, so you really don't need to define a data structure. You can just attach things to the same object and it just, everything automatically happens. It has a built-in DSL, so you can actually define your own functions and function calls and even do some simple arithmetic operations like plus and minus and divide and all that using DSL. So you just define it as a text string and it just understands and parses and does all that with a little bit of legwork. You need to register functions and so on, but it works and it's pretty easy. This is what we did, for instance, for generating the flag emojis to actually define a function call as a DSL. It has a dependency, well, obviously it's Eclipse collections is a dependency and its collections are available to use. It's a good thing that you can use a little bit lower level if you have to. And it's open source with a very helpful and active maintainers that we have been pinging and bugging from time to time, saying, hey, we're trying to do this, it doesn't work, why? It's like, oh, I'm missing this function, can I please contribute and write that? So, I've committed some few things to that one as well, just for fun. I needed that function, the maintainer agreed it was a good idea, and I just did it. It was fun. It's always fun to contribute a little bit back to the open source as well, because we all are on the using side of the open source, but giving back is always a really nice thing. So it's a little bit of the cons, multiple third-party dependencies. Obviously, at least you have two, right? You have Eclipse collections, you have Dataframe. You have, and well, some more if you want to do Jackson.
Does anybody know Dataframe EC?
Dataframe EC? Okay, one.
Okay, one.
Good.
Oh, two.
Two. Ah, nice.
Look at that.
Good, perfect. Well, now you can all of you raise hand next time, right? So minimal available skilled resource. So it's a little bit less. So there is a README file, there is some documentation and everything, but it's less than Eclipse collections. It's obviously less than streams. And it's also a little bit less mature or unevolved compared to all the other alternatives because it's a relatively new and smaller library. But there are other options. There is things, I don't know, like TableSaw, for example.
Does anybody use TableSaw?
Anyone?
Okay.
Yeah, it was almost like half a hand, I think. Yeah. But yeah, so the idea is there are more mature options, but they mostly will be more kind of well integrated with some other tools, reporting tools, and drawing graphs and stuff, and generating stuff. But do what you want, use what you want. We wanted to show you kind of the options of going into the higher level and actually doing Java data-oriented processing there as well. So speaking of that, a little bit of a summary, and then we're done. So data-oriented programming is feasible, flexible, and fun. We really worked hard to get FFF there.
I would say, I think both of us had a lot of fun actually working on this, right?
A lot. So we learned a lot, and we played around with a lot of features, and we've learned actually a few cool tips and tricks that were really sidetracking us from time to time, but we actually learned a lot of cool things. So we played around with Java records. That's not a very new thing anymore. A lot of people have been talking about that and everything. What is a little bit newer and a little bit more kind of bleeding edge is still in preview, actually. It's pattern matching, which was really fun. And also figuring out how do you actually have to do like enable preview and download the latest version.
Put the enable preview in the 1,000 places you have to put it.
Oh, that was fun.
Yeah.
So another thing we played around, well, Java time, that's fine, I guess. Jackson, a lot of people have used that. So CSV library, JSON library for that. We use JUnit for testing. So we created some tests that would run. We have, what you see on the screen is basically ASCII doc pre-printed into a preview. So the whole presentation has been run inside an IDE, and you can actually, there is a button to switch to code mode as well. And we also played around and learned a bit how surrogate pairs work, and that's actually, it's not only flag emojis, it's a bunch of different emojis, especially like when they have several things in one emoji, like several people and stuff, it's actually surrogate pairs of different.
Yeah. And what's interesting with that as well, there's a bunch of code for each of the libraries to do that matching of the pairs and actually coming back with emojis, and each one has its own approach to doing it using the types that are available in the languages. So.
And if you can see on the side.
I'm sorry, libraries.
We kept this as a table of contents, but it's actually a folder inside a repository. And all the other code that we've been talking about, it's in here. They're separated by 3 different folders. Yeah. We also added a bit of an appendix. We're not going to go through that, but it's an appendix and list of links that you can use and play around and try out.
Do you want to bring up the URL?
Everything that you've seen so far, it's in here, so take a picture. So this is my GitHub user, and that's the repository name. It's Java collection Dataframes. And all you've been seeing, like even presentation, is here just as an open source, visible for everyone. Oh, zoom in, yes, please. Sorry. Yeah.
So, I don't know if we have time for maybe a couple questions? Yes.
Yeah. So is this built on top of the Java streams? So basically, my question is, would there be any performance impacts that we should be concerned about while using connections and?
It's a good question. So I think the question is that, are there any performance impacts that you get with using, let's say, either collections or data frame versus using streams? Is that right? The answer is maybe. We didn't actually write any benchmarks for this talk, but it's something I think for maybe upcoming talks we may revisit doing that, just to see what the benefits are. Because Dataframe is interesting being built on Eclipse collections. One of the reasons why it does that is it's a columnar data store. So you don't deal with, let's say, row objects, right? You're dealing with columns where rows will effectively be indexes into the data frame. And what that allows you to do is Dataframe is able to use the primitive collections from Eclipse collections. So if I've got a long column, it's a long, let's say, array list or set, right? So that it's actually not packaging long objects, right? There's no boxing going on there. You've got, let's say, primitive arrays that should be very fast for iteration, should also be more memory efficient. So in terms of performance, there might be memory efficiency versus performance. It's something that we haven't measured yet. It's definitely something that we could.
And versus convenience. Sometimes actually you want to do like, you don't care about the performance, you just want to make it fast, like to implement it, to run it fast, right?
Yep.
I mean, the fastest probably will be like smashing into the spreadsheet and doing all that, but it's worse fun in that, right? I mean, you want to do it programmatically because you want to rerun that and output things, and you get much more control over it.
Yes, sir.
Yeah, I understand your example is relatively simple and contrived, but in most cases, the data frames of code have more lines of code and look more complex. So what are some of the use cases where you're using data frames that make things easier?
So I can tell you like a use case that we used, which was basically just quickly parsing and processing GitHub data for like commits, lines of code added and lines of code deleted, right? So it's publicly available information. You can very easily pull it in via CSV, and you maybe want to like do some slicing and dicing for that. So that was one use case I had. I don't know if there's.
I mean, I have this thing. So there was it's a long story, but there used to be a page where you can, as a speaker, track all your conferences you've been to. That site was bought, taken down, and well, pretty much dead now. I had to export data, and I have to have that data, and I wanted to have some fun with it. For me, it was much easier to play around with data frame objects and just do all the sums and counts instead of like implementing everything low level, because when your data changes, you don't need to re-implement the low-level stuff. You just go on the higher level and you just do small parameter changes maybe and stuff. Because that's one of the things with tinkering with data. Your data sources and data might change, and it probably will change. It's just a question of time. If you implement everything on a low level, then you need to do a bit more work, like fixing it every time. So that is, I think, one of the benefits of doing that. And until I discovered and play around with this, I would have probably gone for another programming language and written a script for that. But you don't want to jump around too much. And I was like, okay, I want to learn this thing, I want to understand this thing, and I'm going to actually see how far I can get. And I got all the way with all the things I wanted to do.
It's interesting because I mean, as Rustam talked about earlier, what we've seen is like a lot of people just go to Dataframe immediately, like if they're working in Python using pandas, right? So I would say like there are a ton of use cases out there. Maybe folks aren't using them in Java, right?
And pandas is way more complex and does much more things, just so that's said. I mean, it's not really comparable in that way, but it's like in use case-wise, it's a similar thing. And it's, but yeah, it's really fun to play around with that. Any other question? One last question until and by the way, on the screen now there at the bottom, it's us, it's our contact information. So this is us on the social media. So just feel free to ping us there and follow. And there will be more data stuff and all the other Java stuff coming.
Since you all were nice enough to attend our talk today, and since you've got the Eclipse Collections Creator in front of you, I have stickers if anybody wants stickers. If laptop stickers are still a thing, I have a laptop that was populated with stickers so many years ago. It's back. But yeah, if you want stickers, just drop by.
Come over.
Yep.
Thank you all for coming.
Thank you.
Enjoy the rest of the conference.